Okay, hi everybody. So I'm Mike Davis. I'm here to talk about taking the fun out of bird watching. So who am I? I'm a builder. Like to build electronics, software, that kind of thing. I also like to break things. So I'm into hacking, infosec, CTFs, that kind of thing. And if you find me in my natural environment, I'll be playing with ham or software-defined radio and just radio in general. So that's kind of how I came upon this topic. It's very similar to dealing with radio frequency stuff, or SDRs, and also like other hard-to-solve kind of niche problems like cryptography. So quick audience participation. Hands up who thinks bird watching is interesting? Nice. Who thinks that it's a fun thing to do? Also, great. How many people have spent a whole day or 2 days in the fields looking at birds? Nice, great. I don't like to do that. I like to spend an hour, and then I start to get a bit bored. I do like birds a lot, but I do get bored, and I've been told it's probably even less than that. So I decided that I would try and automate this. So I like the data processing part. I like to look at the audio, process the audio. Sitting still, not so much. So I started this project. It's an ongoing project, so I've been working on it for a few months. And the idea is to use audio to find birds, then use video and computer vision to track when they move between trees and that kind of thing. And then have a little pan tilt device that can move a camera around and actually record all of that. So, and then I've built a website to stitch that all together and help other fellow bird watchers to make this project better. So the big problem with this, with bird watching is that birds are really good at hiding. So you'll see that's a parakeet on the right-hand side. I've walked past trees where there are literally hundreds of them in the tree and you can't see them at all. They're really good at camouflage, and other birds are too. So you can look for them and spend a lot of time looking for them, but you're going to find a couple that are out in the open. I'm pretty sure that's because of predators and that kind of thing. So, but birds make a lot of noise. So different types of birds make different noises. Some of them are annoying, some of them are beautiful, but I can certainly use that to build a mechanism to track them. So I mean, it's interesting to know why birdsong has evolved the way it has. So I did a bit of research. It seems to be natural selection yet again. And so birds that have increasingly complex songs are sort of selected over ones that don't. And it kind of shows to other mates that they have a more complex brain structure and that kind of thing. Not every bird actually got the message, every bird species. So if you heard a crow, it just makes a very rough sound, and that's pretty much it. But you can still track it. That's great. So the easiest way to go about doing this is, well, not the easiest, sorry, the way that I thought of was to use a technique called beamforming. And you do a lot of that in radios. Most of the radios that you use today, including some of the Wi-Fi access points, and definitely cell phone towers, will use beamforming. Various degrees of complexity. Some of them are super complex, and you can have multiple conversations with lots of different phones at the same time by putting a beam out to each specific device from one tower, which is really cool. So I thought I'd build one for audio, and that's kind of what this thing is. So I'll go through what it is, what it looks like, what it sounds like, and then how it helps with the project. So phase one of the project, microphone array, that's this thing over here. The idea is to take a lot of very cheap microphones and instead of one big expensive one, and then this enables beamforming. So you can put them in a long line and then you can do some math and automate it. So we have 64 MEMS microphones here. MEMS are like really small microphones that you find them in your phones and that kind of thing. It's very interesting to look at the structure of that, but I won't go into it in detail. Just very small. You can pack a lot very closely together. And then to deal with all the pins and the fact that the microphones, you put two together, left and right, So you have to do a bit of clock magic. Used an FPGA for that. And then a thing called an FX3, which gives us an easy way to push a lot of data through a USB port in quite an efficient way. And we can program it as well, which helps a lot. And then in software, we do a lot of math. So it's quite an interesting math problem. And there's lots of libraries that you can use that actually solve this problem already. So one of the problems is with lots of microphones is you normally have to go and sample each microphone individually, which is a tough problem if you've done that before. And if I want to do 64, it's close to impossible. So the idea is to use a microphone that does this thing called PDM, and it literally signals 1 and 0. And if you do that really fast, when the ones are close together, you've got a sort of a high signal, and when they're further apart, you've got something that's lower. So instead of using the kind of amplitude of the wave, you use the density and the closeness. So you can see on the up there, in the middle there's not so dense, and the waveform is actually dropping down, and it gets closer together, it goes up. So that means that I can use something that reads zeros and ones, and that's an FPGA with lots of pins, which really helps a lot. And so then what we can do is you can line up the microphones, 64 of them in the line like that. You know where everyone is, and you know how far apart they are. And then what you do is you make sure that you sample them at exactly the same time. And if you add them all together, you land up with a really nice you get a lot of extra signal. So you get 64 times the amount of signal, roughly speaking. But then if you start doing quite a clever trick where you start shifting which sample they're looking at, you can kind of align it with the signal that's coming in from the bird. So you start delaying the sample that you're processing for each microphone, and you actually start pointing a beam at the bird or the thing that you're trying to track. And if you want to do it in a clever way, you can actually track multiple birds. So if you can do it almost real time for multiple signals, but I've done it for one, and you can see there it basically points one beam across to that bird over there. And it works really well. So I picked the parakeet. It makes this, if you've never heard one, don't listen to it. It's a really terrible sound, but it's like a series of short squawks. And we've got lots of them in my neighborhood, so it's really easy. It's quite loud as well, so it's easy to test for this, this microphone array, or this approach. So this is what it looks like. If you're looking, it's actually inverted, so left is on the bottom and right is on the top. And the bird is coming along, moving sort of behind me and over the microphone, and squawking as it goes, because that's what they do. So it's basically squawking down the left, and then you see it starts shifting over to the right, and it's basically shifting over to the right, and so the signal is going across there, and we're sweeping across to check where it's going. And you'll notice something interesting on the bottom. I'll talk about that in a second, but already you can see that it's working quite nicely. And where those little blue dots is the bird itself. So what is this thing over here? This is a wall that was sitting next to me, and that's the echo of the bird chirping away, and you can see it's not quite as strong a signal and as clear a signal. So you can actually see that it's also 3 meters away, and it doesn't really move because it's more about the signal bouncing off. So I find that kind of cool. We can also get rid of the signal, so we can even not have that problem of an echo in this situation. So you can see from the graph on the right-hand side where we're not aiming the beam, it's like not very much signal. And then as we move closer and closer, steer the beam, we start getting towards the thing that we really care about. And it's about 3 doublings of the signal strength, I think it is, in this picture, between the sort of trough part and the peak part. So it's kind of cool. Okay. So it's really great to find the direction of the bird, but what I want to do also is have a camera track it, and so I want to have focus. I'm not at this point yet, but the next thing to do, all I have to do is add one more microphone and put it about 20 to 30 meters away, and then I can get direction and also the distance. And What we get out of that is we can get some, we can basically find where the bird is in distance and bearing, and then we can triangulate, and then we can actually point a camera at the bird and focus in on it. We can know how far, what the zoom should be, which is really cool for if you want to get close in on the bird. That's my next, sorry, this is what I'm going to do after the next thing I'll talk about. So this is a very fragile piece of hardware. I don't know if you can see it. There you go. It is super janky. It's lots of wires. I got these little boards that have the microphone on them, and then you can just line them up next to each other. It took a long time to build, and behind the scenes here, I'll show you just how bad it is. But when I go into the forest, I get a lot of people looking at me like I'm very strange. You're kind of used to that, but this time I've got a device as well. And it's also hard to move around and very strange. And I wouldn't take this on the tube because I live in London. Gonna get into some trouble. So I plan to make a PCB, a circuit board, which will make this thing a lot more robust and something that I can actually use. And then also perhaps sell to people if they're interested in, if they're doing research or something like that. Also, better microphones. So the microphones I have are not the best, but they work. So I've got a pre-prepared demo, and then I've got another one that I'd like some help from the audience with. But this first one, so we're sitting there in our campsite, and we've got some birds that like to visit us. They have to shout quite loud because EMF camp makes a lot of noise as well. So I thought it'd be interesting to show you what it looks like. This is a video of the tool that I use. Ooh. So you can see on the right-hand side is the null sector. On the left-hand side are some people talking and saying stuff. In the middle is the bird having a little conversation with somebody. So it cheeps every now and then. It's those three little, there we go. Those three little dots were the bird having a cheep. And then, like I said, null sector and people talking on the other side. So it's kind of cool. And then the next, sorry, just one sec. Let's try and see if this works. It's very soft. I'll play it. Hold on a second. I don't know how loud this is going to be, but this is essentially the middle section of the graph of that beam sweep. It's focused just on that, so it should be the bird. Okay. Okay, so you can all hear that. That's super clear. That basically has none of the well, you could hear a little bit of null sector, but I'll play you if we play what happens if we focus on null sector. So you can see that those are very clearly separated, which is exactly what we want. We just want to hear the bird when we've got this automation going. So it works out really, really well. Okay, so let's try the demo. I think I have to just do this. Where's my mouse? Oh, give me a second, sorry. Okay. Okay, let's hope this works. So this is the, you're ahead of the curve. Oh, and it just stopped working. You broke it. I don't think I've ever tried it on another screen. You're gonna, oh, there we go, okay. So can I ask for, wait, hang on. Can I ask for the people on the right to just give a clap? Okay, people in the middle? Ooh. And the people on the left? There you go. I'm so glad that worked. Okay. So, oh, it's off now, sorry. Yeah, it's fun to play with. So the inspiration for this was somebody sent me a video. My daughter over there, sent me this video of visualizing birdsong. Because birdsong is interesting to listen to. It's like that you can sense there's some structure in there, and you can hear that they're having a chat sometimes. But certainly it's hard to visualize, because when you look at it, it's, the standard ways of looking at it are not good enough. So I'm not going to play this, but I'd advise that you have a good look at it. I've got a version of this which is not nearly as good, but I'll show you that in the interest of time. So what it's called is an acoustic manifold. So what you're doing is taking a normal visualization of kind of sound, and you're trying to take that structure that birds have and map it into something that's visually understandable, and you can see the patterns happening. And so we're essentially trying to pick out the normal patterns that birds have, and then use that to build machine learning models to actually understand what kind of bird it is, because the patterns are very clear once you can see them, and you can build a machine learning model that actually understands that kind of space and tells you pretty reliably what the bird is. So we kind of take the normal audio, and we break it out into what are called features. There's a whole bunch of them. I won't go into much detail, but you can pull them out into things like how the frequency changes and the pitch and all that kind of thing into a 40-dimensional space is this particular approach. And then you take all of that and you kind of map it into how it's moving through the space, or over time rather. And then you map it back down into a 3-dimensional space that we can actually look at and understand. If you're doing machine learning models or something like that, you're going to basically just work in that original feature space. And then you could do a bunch of really cool graphics and render them out into videos, or have a real-time sort of view of it, which I've kind of got going. So what you might see is something like this. You might see the bird doing a frequency sweep, which just moves in a line, and then followed by some sort of trill, where I won't try and make the sound, but it's like a sort of repeated noise, and that spins around like that. It comes out with another frequency sweep, and then some sort of simple note looks like that. So this is a very basic example. But yeah, that'll give you a good understanding. This is not quite what mine looks like, if I'm honest. Hold on a second. There we go. Okay. So I have a website that I built that helps me. I basically take a lot of videos of birds, so I put them up there, and a whole lot of automation kicks in, and it builds this for me. This is really not very pretty at the moment, but it gives me all the information that I want, and I think it could be a lot better. I'd like to spend time on it, but at the moment I'm spending all my time on the microphone array. There should be audio for this, so there's no audio. Can you guys hear anything? No. You can hear it? Okay, cool. Well, yeah, so there we go. So you can see, I can't quite see it there, but let me play it again. You can see when it moves out into a specific spot, that's that frequency sweep, and then some sort of movement within that. And this is kind of a real-time approach. So in the field, you could have a look at this if you wanted to, but you can see it's got a bit of structure to it. I'd really like to make this better, but this is the way it is at the moment. That's one bird. And then, I didn't show you the bit where it's actually figured out which bird it is. So at the bottom here, you can kind of have a look at which, I think that's wrong on the right-hand side, but on the left it's a pretty good, it's a great tit. And let me go for this one. This is another one. Maybe it's a bit louder. There you go. I don't know if you saw that, but as it came out, it did that kind of movement through the space. Lucio's visualizations are kind of much better with the tracking and sort of going longer and dimmer. And then here I'll just show you this bit, so you can have a look. Yes. Okay. Did that work? I can't quite see what I'm doing there, but essentially, oh, there, I'm supposed to be clicking that. So you can, it picks out each bird and it tells you what it is, and then you can go have a look at the waveform here, and you can do all sorts of things like that. So there we go. That's that part. Cool. So the thing that I'd really like to get to in the end is to follow a bird. Like it goes to a tree, well, we find it in the tree, and you can find it with audio, and then I'd like to track it. And I've got a pretty good tracking system going. I don't have it here today, but I can show you the video part of it. And essentially what we're doing is, for every frame of the camera that's coming through, we're running a machine learning model that is drawing a box around the bird, and then it is figuring out the next frame what's changed. So where has it moved? So it's alpha beta tracker, and then that essentially gets mapped into pan and tilt, or elevation and azimuth. And that will cause the thing to be slightly ahead of the bird, and then the next frame it can tell where it's going again, and it just tracks the bird quite nicely like that. The fun bit about this is it doesn't just track the bird, it also tracks random things like bees, it tracks airplanes, it tracks all sorts of things, which is where a lot of the work has to go if this is going to work properly. But it's a really good start. Oh yeah, so at the bottom there, servos are, if you've ever worked with servos, they're a bit of a nightmare. They move and then they kind of stop, and then everything shakes a little bit, and sometimes they don't stop properly. So there's a lot in there to try and make that as smooth as possible. So when it knows it's going to change direction, it slows down. And then what we can do is fuse these things together. So hear the bird, figure out what kind of bird it is, see the bird, try have a go at classification, and then whichever one is most confident, you can actually you can say that's what it is, and you've got a nice automated way of finding a bird and then having a video of it and then knowing what it is. So let me show you one more thing on this here. What was the best one? I don't want to just look at that. Sorry, there was a really good one that shows what I'm talking about. Let's try this one here. That's a helicopter. Sorry, that's the wrong thing. But you can see it's a flying thing and it tracks it all the way. That's not what I wanted to show you, I'm sorry. This I could have done better with preparing for. Okay, here you go. So the one thing I love about pigeons or doves, they pretty much sit in the open. They don't hide at all. They're really good test subjects. I'm not sure why they get away with it and the other ones don't, but maybe it's because they're big. But you can see the bird isn't moving, but I am moving my camera around and it's tracking it pretty well. And it has a go at classifying what kind of bird it is, but essentially the tracking is what I care about, because we can do all the rest of it later on. So as long as we've got the video, we can do a lot in the post kind of part of the project. There's lots more. My favorite type of bird is a bird of prey. Okay. So I take a lot of videos of those, and for some reason it's really good at tracking those. Maybe that's ironic, I'm not sure. So classification. I put a lot of effort into this, and I found out that essentially it's really hard. Okay. And so it needs people to help with even, is it a bird or not? So the more is it a bird or not I put into the machine learning model, the better it's gotten. But classification of what type of bird it is a bit of a nightmare. So these 4 birds here, kestrel, sure. Wood pigeon, okay. Red kite, fine. A rook, fine. That's a goose for sure. Parakeet, yes. A dove, yes. And an airplane. So that's not a bird. And it keeps trying to track airplanes. Don't ask me why. So I've built the website. It's there. You can sign up if you want to upload videos and do things with it. You can upload video, audio, and most importantly for this project, just help me label things. The labeling is the hard part. It takes a bit of time, but it's very easy. If you feel like donating a GPU, you just basically run a binary on your machine, and then it just does all the processing. And so it's fun for everybody. Yeah, and that's it from my side.